Okay, so welcome to the channel, and today we are going to see Young Tutor's view on the development of the heart tube. You know, it reaches that time when the embryo in the third week, when it cannot satisfy its nutritional and oxygen needs by diffusion alone. So the cardiogenic area or development of the cardiovascular system comes in precautiously to help satisfaction of the embryo in terms of oxygen and nutrition. So stay tuned as we are seeing Young Tutor's view on the development of the heart tube. Okay, so let's start by seeing where the cardiogenic area is on the gastrula or the trilaminar disc. So the cardiogenic area in the third week of development is gonna be on the mesoderm. So on the mesoderm is just between the ectoderm above and the endoderm below. So let's begin by just bringing this illustration closer so that we see parts of the mesoderm and where exactly the cardiogenic area is going to develop. So the mesoderm is going to be separated by the notochord, that is the notochord, and on the left side and on the right side we have the same thing. So I'm going to show you the parts of the mesoderm on the left side. So what we have is the paraxial mesoderm just proximal to the notochord. Here we have the paraxial mesoderm, and then the following one here is the intermediate mesoderm. That is the intermediate mesoderm that is following the paraxial mesoderm on the left side. Then we have this one. This is the lateral plate mesoderm, which is going to have two parts: the somatic mesoderm here and the splanchnic mesoderm over here. So these two are going to be separated by the intraembryonic coelom, a cavity. This here, we show it nicely. This side, this is the splanchnic mesoderm and this is the somatic mesoderm. Between them, there's a separation, the intraembryonic coelom. This one forms on the lateral plate mesoderm because of intraembryonic cavities that develop on the lateral plate mesoderm to separate it into the somatic part and the splanchnic part over here. So those are the parts of the lateral plate mesoderm. So we have the somatic and the splanchnic mesoderm. And what we are interested in this view is the splanchnic mesoderm, because that is where we are going to have the cardiogenic area developing from. So that splanchnic mesoderm on both sides, on the left and on the right side, is what we are interested in, because that is where we are going to have the cardiogenic area. So the cardiogenic area is going to have two parts. It's going to have the primary and the secondary heart fields. Yeah, so those two fields are going to make up the cardiogenic area, and these two parts are going to make up the endocardial tubes. Endocardial tubes, both the right endocardial tube and the left endocardial tube. And we are going to see that the endocardial tubes are the ones that are going to come together, influenced by some folds, in order to form the heart tube. So how does that happen? We are going to see. So let's go into it and see how this happens. Okay, so I have deliberately removed this part, the splanchnic part of the mesoderm, so that you see how it's formed before it's actually called the splanchnic mesoderm. Something happens here because that is where we are going to have the cardiogenic area. So before the mesoderm forms, this is not a gastrula, it is actually a blastula. So over here we are going to see the epiblast. The hypoblast is supposed to be down here. So from the epiblast, before this becomes a gastrula in the third week of development, This is the epiblast. So we have cells from the epiblast that migrate to this part here to form the cardiogenic area. So those cells are called progenitor cells. They migrate from the epiblast and then they come at this area to form the primary heart field. I said earlier to say the cardiogenic area here is supposed to have two parts, the primary heart field and the secondary heart field. So this is how the primary heart field is formed. Progenitor cells are going to be migrating like that from the epiblast to this area here, the cardiogenic area, to form the primary heart field. So these cells are progenitor cardiac cells. The progenitor cardiac cells have migrated from the epiblast to this area to form the primary heart field, one of the parts of the cardiogenic area. So those are progenitor cells, and what we have here is the endoderm. The endoderm actually stimulates the differentiation of these progenitor cells so that they form blood islands, or those tubes, endocardial tubes that we talked about. So you can call them endocardial vessels or blood vessels. Yeah, you can call them that. So those blood islands that form here by differentiation of the progenitor cells are going to form our endocardial vessels, and that process is called vasculogenesis. Yeah, so that is the primary heart field formation. So in the primary heart field, we have these progenitor cells forming the endocardial tubes via the process of vasculogenesis. Okay, so let's continue from here to see what is happening to the primary heart field. This primary heart field and this area are separated by the intraembryonic coelom here, shown this side, and this is the primary heart field here. Very important point here is that the primary heart field here is inferior to the intraembryonic coelom, as you can see here. But something is going to happen after the cranial folds or fold of the head. There will be exchange of positions of the intraembryonic coelom and the primary heart field. We are going to see after the cranial folding that the primary heart field is going to be above the intraembryonic coelom. So let's see what is happening here. So the cranial foldings are happening such that this primary heart field is folding in that manner, and this other part also is also folding in that manner. So we are going to see that this here, the intraembryonic coelom, which was initially above before the cranial foldings, cranial caudal foldings, it was above the primary heart field, but after the foldings we can see that now it is below. The primary heart field is now above the intraembryonic coelom. This is very important. You are going to see the importance as we go on in the video. So these cranial caudal foldings are making the heart, which was cranially, to move in the position that is more caudal, and it's going to find itself in the thoracic region. So primarily the heart begins to form, or the primary heart field begins to form in the cranial region, but after these cranial caudal foldings or folding of the head like this makes this intraembryonic coelom and the primary heart field to come in the thoracic region like this. So this is very important. Yeah, so let's show this part here in another illustration down here. So in this illustration we still have the intraembryonic coelom here, and the primary heart field is going to be here. So now we have that exchange of positions of these two because of the cranial folding or folding of the head. So we have the primary heart field, and we say that the cardiogenic area is not just going to have the primary heart field alone. So where is the secondary heart field coming from? So let's illustrate that in a minute. So we have the mesoderm here where we are going to have cells coming from. So the cells that make up the secondary heart field actually come from the ventropharyngeal wall of the mesoderm. So we are going to have cells that are coming from there. They are migrating to this area, the cardiogenic area, to make up the secondary heart field. So very few cells, because they are going to do a very simple task to the heart. They are just going to be responsible for the formation of those outflow parts or the smooth parts of the ventricles. They also form just some part of the right ventricle. So the secondary heart field doesn't do much, but it's going to contribute to the outflow parts of the ventricles and even some part of the right ventricle there. Okay, so let's just bring this illustration here close so that we see what is next. So from here we know that we already have the endocardial tubes here fully formed, because they have both the secondary heart field and the primary heart field. We know that the primary heart field in the endocardial tubes is going to be responsible for other parts of the heart, but the secondary heart field, very important, it will also form those outflow parts of the ventricles and some part of the right ventricle. So what is going to happen next? I want to introduce to you the lateral foldings that are going to be pushing these endocardial tubes that have formed in the cardiogenic area on both sides. The lateral foldings closing the ventral wall are going to be pushing the intraembryonic coelom, even the primary and the secondary heart field or the endocardial tubes, pushing them towards each other. So these lateral foldings are going to make these two to merge. The intraembryonic coelom is going to merge. Even these endocardial tubes, both on the left and on the right, are going to merge to form one thing. So I'm going to be illustrating down here what is happening here because of lateral foldings. So because of lateral foldings, we are going to have intraembryonic coelom merging to form one cavity here. And you know, because this cavity has gone differentiation, it's going to be called another special name called pericardial cavity. And now we are going to see the importance of this cavity, that exchange that happens, that the cavity is below the cardiogenic area. So let's see what is happening again. Because of the lateral foldings, these endocardial tubes will be forced to come together and form one heart tube like this. Yeah, so I'm just illustrating what is happening here, down here. So we have just observed that two endocardial tubes on the left and on the right have come together to form one heart tube like this. So the fusion is happening on the center. We can see that the ends, both the venous end of the heart tube and the arterial end, are unfused. Yeah, so the fusion is happening on the center like that to form this whole heart tube here. So the heart tube is formed from the fusion of the endocardial tubes, both the right and the left endocardial tube over here. So we have our heart tube here, which is on top of the pericardial cavity, this one here. This is very important because when the heart begins to loop, when cardiac looping begins to happen, we are going to see that this heart, as it is folding during the cardiac looping, it's going to find itself inside the pericardial cavity and it will develop inside there. So the heart tube has developed like that. So that is how the heart tube develops. So what we are going to do to conclude this view is just to see the parts of the heart tube. So we are just going to bring the heart tube close like this so that we can see its parts. So it is having the arterial end over there and the venous end over there. It has three constrictions or grooves. One, the bulboventricular groove or constriction, the atrioventricular groove or constriction, the sinoatrial groove or constriction. So these three constrictions are just dividing the heart tube into four parts. The first part on the atrial end here is the bulbus cordis, like that. So this part, bulbus cordis, has three parts: the upper 1/3, middle 1/3, and the lower 1/3. So the upper 1/3 is called the truncus arteriosus, and the middle 1/3 is called the conus cordis, and then the lower 1/3 without a specific name, but it is very important, lower 1/3. Then here we have the primitive ventricle, here we have the primitive atria, and here this is the sinus venosus. The sinus venosus, because this end is unfused, it has the left horn here and the right horn. These horns are supposed to receive veins. So veins that are received by the horns are three on both sides. So three here, even three this side. So what are the names of these veins that are received by the horns of the sinus venosus? So we have a vein called vitelline vein from the yolk sac. So one of the veins is coming from the yolk sac and it is called the vitelline vein. And then the other one that we have here is the umbilical vein from the umbilical cord. And the last one, or the third one, is the cardinal vein, common cardinal vein, which is formed by the fusion. It is formed due to the fusion of the anterior and the posterior cardinal veins. So we have these three veins that are received by the left horn and the right horn. The last thing that we are going to talk about, since we've talked about the parts of the heart tube, is just the fate of these parts. Let's just begin with the parts of the bulbus cordis. The upper 1/3, the truncus arteriosus, is the one that is going to form the ascending aorta, even the pulmonary trunk over there. Then this one, conus cordis, middle 1/3 of the bulbus cordis, is going to form the smooth parts of the ventricles. Those smooth parts on the right side, we have the infundibulum. It's also called the conus arteriosus. That one is the outflow part of the right ventricle. And then on the left ventricle, we have the aortic vestibule. The aortic vestibule is the smooth part or outflow part of the left ventricle. Okay, so this lower part, lower 1/3 of the bulbus cordis, the one with no specific name, what is it forming? It is very important in the formation of the rough part of the right ventricle. The primitive ventricle, very important in the formation of the rough part of the left ventricle. Primitive atria is going to form actually the rough parts of both atria. And then the sinus venosus has got two parts. This is the body of the sinus venosus, and this is the right horn of the sinus venosus over there. Those two fuse. When they fuse together, they form the smooth parts of the right atria. even the roots of the IVC and the SVC. You know, the IVC and the SVC both are opening in the right atria. So what is responsible for the formation of those roots of the IVC and the SVC, even the smooth part of the right atria, these two parts, body of the sinus venosus, even the right horn. Okay, so the question will be now, what is the left horn going to do over here? So this one is going to degenerate. So that one, as it degenerates, the left horn degenerates, but before it does that, it contributes to the formation of the coronary sinus, even the oblique vein of the left atria. So it has those contributions before it degenerates, but generally it has to degenerate. So how do you know these parts here, like the fate of the heart tube? So very simple, because you know these rough parts are adjacent to each other. So the parts of the heart tube that are forming the rough parts on the heart are actually adjacent to each other, as you can see, rough. These parts here, the lower 1/3 of the bulbous cordis, the primitive ventricle, the primitive atria, all these are responsible for formation of the rough parts of the heart. And then smooth parts of the heart, those parts of the heart tube that are forming the smooth parts of the heart are actually apart from each other. You can see what is forming the smooth parts as the conus cordis, middle 1/3 of the heart tube, even the sinus venosus. You can see these two parts are apart from each other. So smooth parts apart, the rough parts adjacent to each other. That's how you know the fate of the heart tube, the parts of it, and you're able to remember, because these rough parts are adjacent, smooth parts are just apart from each other. Yeah. So thank you so much for watching. That was Young Tutor's view on the development of the heart tube. So if you find this information to be useful, just remember to like, share, and subscribe to this channel for more content like this. For now, bye bye. See you in the next Young Tutor's view.